Hello, welcome back. Looking at what you've been waiting for. Triangles, things from freshman geometry that you forgot. Just go ahead and flip your packet over and let's write down some triangle formulas. Because I suspect there's a few that we've forgotten. Let's just kind of draw ourselves a triangle here. Whoop, great. We gotta label this thing. How are we gonna label this thing? We're gonna call the longest side kind of side C. So if this is side C, we'll call these legs A and B. So we call C the longest side. That's the hypotenuse. Longest side, call that side the hypotenuse. It's always the longest side's always the hypotenuse. We only tend to call it that though when we're talking about right triangles, but it's always true. These shorter two sides, call these legs. They're shorter. All right, so what do we know about some triangles? Oh, I also need to know that the largest angle is opposite the longest side. All right, so something to write down to the side. Largest angle goes along with the longest side. Also, smallest angle, it's going to go along with the shortest side. It's not immediately obvious to me which one's the shortest over there. Okay, so just some definitions of triangles. All right, what are some things we know about triangles? I'm going to finish labeling this thing. This will be called like angle A. I'll put a capital A in there, and I'll put a capital B up here. So by convention, you know, the angle and the side opposite are going to have the same name, or maybe a capitalized version. All right, so we got some triangle formulas. Some things we need to know. Okay, well, the longest side, C, is always going to be shorter than the sum of the other two sides, A plus B. That's your triangle inequality. It's a useful formula to you. Call that the triangle inequality. You can mess around with it a little more. You can modify it. You may have seen it with an absolute value in there somewhere, but that's the form we're actually going to need to do well in the ACT. All right, so there's a few formulas. What else do we know? Ooh, maybe one you know. The sum of the angles in a triangle. Hopefully you know adds up to 180 degrees. That's a good one. What else do you need to know about triangles? Ooh, maybe we need to know the perimeter of a triangle. That's A plus B plus C. Okay, that's a good one. Just add up the side lengths. How do we find the area? Area of a triangle. 1/2 base times height. So going up here to this this triangle up above, I happen to put B as the base here, but the height isn't drawn on here just yet. Let me take out a pen of another color and remind you what that height would look like. Technically, it'd be, that would be your H, your height there. Cool. So we can find area triangle, base of a triangle. Some of the angles going to have to do that a lot. Going to be given like a couple angles. Going to be asked for a third. Let's remind ourselves about similar triangles. What the heck are similar triangles? Similar triangles, well, what do they have? They have the same angles. But they're just going to be different sizes. Same angle measures, but they might not. They might be like stretched. One might be bigger than the other. Let's draw a couple similar triangles here. Going to call this A ABC. Let's make it a right triangle just for fun. And we could have a bigger triangle. ABC, D, E, F. And how would I know they're similar? I'd do something like this. I'd say this angle equals that angle. This angle equals that angle. So different, same angle measures, but can have different side lengths. So we're going to say also they have same angle measurements, same ratios of side lengths. Well, what the heck does that mean? We could say something like, for angle here, triangle ABC, can say it's similar to triangle DEF. Now, what is that going to mean? Well, that means like if this is side C, this is side A, this is side B, this would be little E, little D, little F. It'd be something like, well, A over C, this side over this side, equals D over F. Why does that make sense? Well, those are the sides on the top. Those are the sides on the bottom. The ratios of the side lengths are the same in similar triangles. Useful for us. Okay, what the heck else do we really need to know about triangles? Not a ton more. Down here at the bottom, I'm going to remind you of a couple things. Hopefully you remember what an isosceles triangle is. Maybe you can spell it. That's hard sometimes. Isosceles triangle. What's an isosceles triangle have? Two side lengths that are the same, and the angles opposite them are the same. What's the other kind of weird triangle? Equilateral triangle. Equilateral, they're all equal. And since the sides are all equal, the angles are also going to be all equal. They're all going to be 60-degree angles. All right, so isosceles and equilateral. We can remember those two special types of triangles. Got one last thing I want to show you real quick. You don't have to know this one, but it ends up being helpful sometimes. These are your special triangles. What am I talking about? Special triangles. Talking about 45, 45, 90. Not going to derive these, but if you remember, these have ratios of side lengths 1 square root of 2, comes the Pythagorean theorem. Probably should write that down too. My other special triangle, my 30, 60, 90, 30, 60, right angle 90. What are my ratios there? 1 square root of 3 and 2. And the other thing I'm going to write down, which hopefully you knew, but I will remind us of, for right triangles, a squared plus b squared equals c squared. These are the things I think you really need to know for most of y'all to be successful in like the mid-20s range. If you want to be extra, there's a few more I'm going to show you. I'm going to reference them in the video. Let's stop. Let's work through like 12 of these together. So got a few circled I want to work through in a figure shown below. Oh my God, triangles, this looks scary. E and G lie on AC. Okay, E and G lie on AC, and D and F lie on AB. Great. DE and FG are parallel. DE and FG are parallel to BC. Okay, parallel, parallel, parallel. Great. And the given lengths are in feet. What is the length of AC in feet? So I want to know, what's this big length? Okay, well, what do I know about? I don't know about the big length. I know about the side I know about the other side, and I know one of the short lengths. Let's look at this little tiny triangle here, like ADE, this little blue triangle here. I see that this little triangle ADE it's going to be similar to this bigger triangle ABC. What am I talking about? Well, they have the same angle up here at the top. And this angle here on the side is going to be the same as this angle down here on the side. How do I know that? It's a parallel bisector. It's a bisector of two parallel lines. Going to create the same angle there. Same deal on this other side. Cutting across those two parallel lines, we're going to make the same angle. So if we're making the same angle, we've got similar triangles. What do I mean here? The triangle ADE, bop, 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 this triangle is similar to a bigger triangle, ABC. Why is that helpful to me? Because now if I can say that the side lengths, the ratios of the side lengths are equal, I can figure about this unknown side length, because I know that 6/12, that's the ratio of the left leg to this hypotenuse here. So I'm going to write 6/12 equals what? Well, the long side of the larger triangle, which is 6 + 5 + 4, which is 15, over AC, which is the unknown, which is the x. What the heck is x here? The long side. I can see the ratio here is 1 to 2, either through cross multiplication or by looking at it. You can figure out that x here must be equal to 30. And we're getting an answer of D on number 1. Kind of a tricky one with similar triangles. You guys see these two triangles are just one version scaled up to another version. Rectangle shown in the figure below is partitioned into 3 triangles, 2 of which are shaded. What's the total area in square inches of the 2 shaded regions? A couple ways you can attack this problem, but you really got to know that the area of a triangle is 1/2 base times height, so half. A couple ways you can do this. You can find that the area of the big rectangle is going to be 80. How do I get that? 8 times 10 is 80. Maybe I could take away the area of the unshaded part. Well, 1/2 base times height. Think about this. The area shaded equals the area of the rectangle minus the area of the unshaded. Well, the unshaded region is a triangle too. So this could be 80 minus 1/2 of 80, 10 times 8, which is going to pretty clearly give you 40. So just as we can have some long ones where we got to say similar triangles, we're going to have some short ones where we just have to calculate the area. Number 4 is a weird one. I'm going to do number 4, mostly because I don't think any of you are going to have any idea what you need to be doing on this. Set of lengths of a certain triangle are 4, 5, and 7. Which of the following descriptions best classifies this triangle? All right, you don't know. So let me tell you here. We got a couple relations with a squared plus b squared relative to c squared. You know, if they're equal, that's going to be a right triangle. But maybe you know that 4 squared, 5 squared, that makes, well, 4 squared is 16, 5 squared is 25, that makes 41. That ain't 7 squared. So I'm going to tell you right now, it's not going to be a right triangle, especially I know it's not going to be isosceles. I can cross out J and K without knowing anything, without knowing much, because I see that all 3 side lengths are different. Remember, isosceles would be 2 same sides. So right away I can cross out J and K just because I know what an isosceles triangle is. But then you're saying, how the heck do I know whether it's acute or obtuse at that point? Got a relationship with A, B, and C. If a squared plus b squared is greater than c squared, that's going to be an acute triangle. And if a squared plus b squared is less than c squared, that's going to be an obtuse triangle. In this case, 4 squared and 5 squared, that's 41. How does that relate to 7 squared? 7 squared is 49. So c squared is larger. So this is going to be an obtuse triangle, scaling obtuse. Cool. Scaling, now the side lengths are the same, as you'll recall. So first side, not too bad. We got a kind of a goofy, tricky one down here. Hopefully a pretty easy one on number 2, and then one that some of us maybe are getting on number 1. Let's keep going. Let's do a few more. Some of these are just going to be like algebra. Number 6, the dimensions of equilateral triangle. Equilateral, same sides, are given in centimeters below. What's the value of y? Well, how the heck am I going to figure out y till I know what something else is equal to? I see that these two, well, all these are going to be equal. They're all going to end up being equal. But I need to solve for one variable, x, before I can then solve for y. So let's set 3x plus 1 equals 5x minus 9. Do a little algebra up there. And you're going to move everything over here on the right, get 10, numbers on the left, variables on the right. We're going to find that x is 5. Okay, well, if x is 5, then we know that this side is 3 times 5 plus 1. That's 16. They're all 16. It's an equilateral triangle. So this is 16. So this is 16. So if I have y plus 3 is 16, the littlest bit of algebra gets me to y is 13. Answer J there. Number 7, I like questions like number 7 because you guys forget them. What do linear angles add up to? What did you have to know? Linear angles sum to 180. What do you got to know here? What am I talking about? You want to know x. You don't know x. And you don't know this other angle. But if we know this other angle, and if I know it's 80, well, then I can figure out everything else. How did I know it's 80? Well, I know that these two angles had to add up to 180. So that's what's giving me 80 there. So how do I find x? 80 plus 65 plus x equals 180. 80 and 65 make 145 plus x is 180. A little bit of subtraction there, and I find that x is C, 35. So linear angles sum to 180, and triangle angles also sum to 180. Got to know that. Ooh, okay, we're heating up. Number 8. In ABC shown below, the measure of angle A is 48. And what the heck does that mean? Congruent. They have the same side length. AB is congruent to AC. What's the measure of angle A, measure C? Well, whatever it is, it's going to be the same as this angle over here. That's x, and that's x too. All right, what do you have to know? You have to know that 2x plus 48 is going to equal 180. The angles in this triangle have to add up to 180, and two of them are the same. What kind of triangle is this? It's an isosceles triangle. 2x is equal to 180 minus 48 is 132. 132 divided by 2, I think, is 66. Answer there is going to be J. Okay. Add up to 180. We can do this. Set side lengths equal. We can do this. Let's skip ahead. Let's skip ahead to number 13. And I'm looking at that and I'm saying, oh, that's similar triangles. Sides AB and BC are both 7.2 centimeters long. Side DE is 10.8 centimeters long. And the measure of angle E is 42. What's the measure of angle C? Oh, it's the same kind of problem. If they're similar, then I know this is 42 as well, because they're similar. All right. What's the measure of angle C? Well, I don't even, what do I know here? That's measure C, angle C. It's the same problem once again, folks. It's a very similar problem, but in this case, it's 42 plus 2x equals 180. 2x is 100 and what is that? 38. X has got to be 69 in that case, but a very similar triangle. Once you see similar angles, isosceles triangle, once you saw it was an isosceles triangle and you knew they were similar triangles, you can take the 42 over, and then you know the other two angles are equal, and we can solve this pretty quickly. Which of the following lists of numbers could be the side lengths in inches of a triangle? Sometimes you see this problem, and if you don't know the formula, you don't know what the heck is going on. What is the relevant formula here? The relevant formula is that C is less than A plus B, where C is the longest side, and A and B are the legs, which are obviously shorter. So you need to find which case is the longest side shorter than the sum of the other two sides. What am I looking here? Is 3 less than 1 plus 2? No. Is 7 less than 2 plus 5? No, it's equal. Is 11 less than 3 plus 7? No, it's greater than. J doesn't work. You're going to find that 10 is less than 5 plus 8. 10 is less than 13. That's true. Answer on that one is J. So sometimes we got to know a little bit about triangle inequalities. Not a real common one, but if it shows up, it's so easy. You'd like to get it right. Number 17, maybe some words you've forgotten. What's the length and coordinate units of the altitude? Well, the altitude from C to AB. The altitude, what is that? It will be perpendicular to AB. What am I talking about? The altitude is going to go straight down. It's going to form a right angle there. What is the length in coordinate units from C to AB of this altitude? Well, it goes straight down, parallel to the y-axis. The only thing that's changing here is the y coordinate. It goes from 4 to 3 to 2 down to a y coordinate of 1. 4 minus 1 is 3. Not bad on that one. A couple others I want to do. Prepare us a little bit for some trig next week. Just a soft intro. Not a ton of trig problems in this packet, but there's a few. In ABC shown below, sine of C equals 4 over 5, and the length of AB is 10 inches. What is the length in inches of AC? All right, so I know about C. That's the angle right here. All right, well, what does the sine tell me about? The sine of an angle tells me about the opposite over the hypotenuse. 10 is the opposite side. The unknown is the hypotenuse. So I'm saying 4 over 5 equals opposite over hypotenuse. The opposite side is 10. The hypotenuse is the unknown. I'm going to call it x. Got to do a little math there, solve for x. X is going to be equal to 50 over 4, which reduces to 25 over 2, which is our answer there of E. Not a hard question if you know what sine is. Sine is a ratio of side lengths. We knew one of the side lengths gave us enough to find the other side length. Let's do one more. Call it good there after 22, and you guys will have some work to do on this one. In the figure below, AE and BD intersect at C, and what the AB double line DE, that means they are parallel. And we happen to know which of the following angles must have the same measure as BAC. BAC is right here. And we got a rule says, we got two parallel lines. We cut them. Those angles formed on the inside there are going to be equal. This CED, this angle right here, is going to be equal. Answer there. Okay. Cutting up those parallel lines. Cutting up those dang parallel lines. I think I'm going to stop it there. Leave the video at that length. You've got a whole bunch of triangle problems to solve. Whole bunch. Set to work on them. I'll be wandering around. Ask me some questions, and we will figure it out.